So welcome, welcome. We'll just start early today, just for fun. Just to throw people under the bus. How are things? How is your lab? Thumbs up, thumbs up. Various signs of, I don't know how to interpret. So how many people have made some progress on your lab? Great, okay, perfect. So remember that I have office hours at 1. So if you have any questions or you're stuck on something or you just want to vent, you can come over and get one. I'll be happy to give you some time. So today we're going to change course a little bit. We've talked a lot about binary exploitation. We've gone down the rabbit hole of understanding what's happening inside x86 assembly, inside Linux and Windows and some others. And we're going to now look at a completely new target, which is the web. Yeah. So this should be fun. So we're going to have like this ocean of slides here and some fun concepts that we're going to learn. We're going to talk about web security and something called OWASP Top 10, which is a list of the 10 most common vulnerabilities. It's done every single year. It's updated. And some of the things we're talking about today are and have been on the list for the past decade or so. So we have always a consistent amount of new vulnerabilities coming out on the web that somehow just don't go away. This is what Anonymous uses to attack everyone. This is what the Chinese military, as well as the Chinese kind of espionage units use for attacks. And it's used occasionally. It's a very common form of attacking. It's also very simple. I won't go through that. So let's get to it. If this works. So how many people have taken some courses or at least know something about how the web really works? 1 person, thank you. Half, 1.5 people. Okay, there's this thing called the Google Web. It has like all sorts of content and cat videos and stuff. It's amazing, right? You check it out. So among the things that you do on the web is that you open up your browser and you want to see stuff. Like, I want to see a kitty video. And so suppose that you enter in your bar like a particular URL, a universal resource locator. You put in here something, and the browser will figure out that, oh, I'm supposed to contact this server over here. This server here running, say, an Apache web server or PHP something. How does it know that this is the server? Well, it looks at this URL. It looks at the first part of it before the first slash, which is the domain name. In the context so-called DNS server, which we'll learn about a few classes from now. It figures out that, like, oh, there's this IP address attached to the server. I'm going to send a TCP packet to that server. I'm going to send in some content along with the request, and we'll see what it looks like in just a little bit. And then the server is going to be like, hey, I'm supposed to render the content from this person over there. I'm supposed to render something called folder and then page, and I'm supposed to provide it with the argument ID equals 5. What it does is that it runs PHP, just a programming language used by the web, on the server side to create an HTML page to send back. And as part of doing that, what it's going to do is that it's going to issue a database query to its own SQL server. This could be Microsoft SQL Server, it could be a completely separate machine, it could be MySQL, a variety of different servers. SQL is a database, SQL is a structured query language for databases. So if you have a relational database, which we've talked about later in the past, and you want to store some content, this is how you talk to that server. Okay? So it may be asking questions like, hey, who is this guy number 5 here? Oh, it's that guy over there. So I'm going to customize my web page for that to be in there. Back, it sends a bunch of content. It includes images. It includes the HTML page itself. Thank you so much. And CSS, which is something just to figure out layout. And a variety of other things. Okay? That's a typical request. So far, nothing bad has happened, right? So now that all this HTML and all this JavaScript and stuff is back from the server, which is just like a big, it's this big kind of smorgasbord of content, the next thing that happens is that the browser is going to try to interpret it and try to create a layout from it, right? So it looks at the HTML and tries to create a tree out of everything that's happening inside the HTML. It's called the DOM tree, Document Object Model. So it figures out here's the document, here's the head of the document, and under that there's the title of the page, which is the thing that comes in the title of the browser itself, the body, and then it has an anchor, and the anchor has a value, so forth, right? Giant tree. And then it talks to its renderer to try to place everything, put in all the pictures and so on. That's how the web works in a nutshell, okay? All clear? Okay, great. Now you understand the web a little bit. Now, the way you interact with the server, that initial request, uses a protocol called HTTP, which is why you write HTTP : // You say, hey, there's a particular way in which I want to communicate with the server. And the HTTP protocol is a text-based protocol that has several different types of requests, the most common of which are GET requests and POST requests. Anyone know the difference? Yeah, some people. Yeah.
GET requests retrieve information, whereas POST requests send it. They're like submitting.
A little bit, yeah. In both cases, you get information back. In a GET, go ahead.
Get sends a query into the URL.
Yeah, as a part of the URL, you send all the. So for instance, here, ID = 5 is additional information submitted with the GET request. Whereas if you want to, for instance, log on or something, you never see your password as a part of the URL. Have you noticed that? It was hit like login or something. That's because it's sent by a POST request. It's used for form submission or for sending a file or something that's kind of bigger. Or if you want to be a little bit more secretive about it, you use POST submissions. Not a huge difference, but some. Make sense? Great. Now, when we talk about the web, and because the browser is pretty much the most insecure part of your computer, there's a number of different types of attacks that we can imagine here. And they're going to be a little bit different from the types of attacks we've been talking about in the past, right? We've been talking about usually some malicious person with permission attacking a server, or possibly compromising a user and then using that to log onto a different server. Okay? Here we're going to have a variety of different setups. It's kind of important that you kind of pay attention to what the threat models are. This is something that, as you start working in the security industry, is one of the first questions that come up with if you're thinking about security of your organization. What is the threat model? What does the threat model mean? Who's going to attack you? What kind of an organization can attack you? What kind of resources do they have? How are they going to attack you? What can they control? What cannot they control? What do you assume is safe, what is not safe, and so forth, right? So here, for instance, one threat model would be that there's a malicious client attacking a poor little server, right? And these are called, there's a variety of different types of attacks. One of them is called injection, which we'll talk about. SQL injection, for instance. File system traversal. Suppose that instead of saying like, hey, can you open up index.html, which would be an HTML file on the server, I say, can you open up the file etc pathwd, or like some file that you're not supposed to have access to. So if the server is unaware that it should just stay in its own directory and be like, oh yeah, that sounds good, I'm going to go to .. which is the parent directory, and the parent directory and so forth, and then it just gets any file in the server that access to it. Look at an example of file system traversal, right? Broken access control. What if the server is trying to keep you out in some way and doesn't check you properly? For instance, it may send you a cookie that says, we'll talk about cookies in a little bit, but the idea of a cookie is that you always send it back with any request. What if I give you a cookie that says, I have authenticated you, just bring that back, like, just let me know that I've authenticated you before, right? Does that sound safe? So a malicious person is like, hello, I am authenticated, you authenticate before, right? Oh yeah, thank you. Just move along, right? That obviously doesn't work. So we have to think about how we authenticate users. So broken access control is a big thing here. Now we could also have a separate type of a threat model where the server is attacking some poor little client. What would be an example of that? Where it says clickjacking, right? There's a server that like presents you with something that looks like a legitimate content, and when you click on it, you're not actually clicking on the link you thought you were clicking on. You're clicking on something like something on Facebook, or authenticate somebody to execute the script on your browser, or any other thing, right? Transferring money to your friend or to your friend, right? Yeah, really. History probing, figuring out where you guys have been, and then sending that to the Democratic National Convention or whatever it is that you do, right? Knowing where you've been is something that a lot of servers might be very interested in, right? Phishing. We talked about phishing a bit, right? Remember? Yes, what is phishing?
Pretending to be a legitimate
Yes. Welcome to Bank of America. You type password. Yes. You need PIN too, please. Right? Phishing. all sorts of things. So then you can have it even more complicated, right? We can have these triads of things. We can have a malicious user over here on the left trying to attack other users. Ah, now this has actually been pretty transformative since, in comparison to the types of overflows we've been talking about in Linux and control flow, hijacks, and so forth. This is what you need if you want to try to steal information, which is by and large what hacking is about today. The previous types of attacks I've been talking about are yeah, you can steal information, but they're about controlling somebody else's computer, right? Owning somebody's node, right? Here, you don't particularly care about the server. You just care about who else is using the server, and then you want to get access to their computer or their inbox or whatever, right? So this would be examples of cross-site scripting, where I put in code that somebody else who visits the same page will execute. Same thing for cross-site request forgery, a variant of the same attack. Remote script inclusion. When you open up a page and it includes a variety of different JavaScript stuff, well, what if one of those JavaScript things is something malicious that sends your cookies away, or opens up your history and submits it, or figures out what Facebook login is? That could be bad. Right. Or you could have another threat here where you have a malicious server who is in a mashup web application. What would be an example of this? So this is, again, something that supports clickjacking. So this could be something like you have a server that's, yeah, I mean, it's the same example as before. You have a server that's serving content, and a part of it is served off of a different node, and if that node gets compromised, or for instance, something that actually happens is that you have information on your domains, and then when you get tired of it, your domain expires. Well, guess who buys those domains? You do. Oh, yeah, that's right. Why would you buy them, right? Because not everybody who previously relied on the stuff that's in your domains is going to open up your page, or you're going to have a high page rank as a result of having a legitimate site that people link to. And therefore, what you put it there, it's like, oh, we included like the JavaScript that was on some website that's no longer functional. Well, that JavaScript's not going to get replaced with something very nefarious, right? Ads, for instance. Somebody found out that like all these double-click ads, you were able to actually sign up with an ad that had code inside of it, so that everybody who like opened up a legitimate site like CNN.com would get like a little ad iframe, and in the ad iframe it was trying to like figure out if you were susceptible to several types of malware and other fun stuff like that. Yes. We're talking again, information stealing, all sorts of good stuff here. Or you can have a malicious user in a multi-server application where like you're contacting different sites. That could be, for instance, you contact Facebook to allow some other app from a completely different server to get access to your account, right? But what if you misrepresent this information, or you don't send it onwards, or you authenticate a completely different app, right? You can sign in as someone else, also knowing that you pretend effectively to be the intermediary. Buying things for free, right? What if you intercept the whole protocol that's used for payment, right? You're in the chain of where authentication happens, and you just snatch out of it and say, like, no, actually, I'm going to replace it. We'll take examples of these things. But the point here is you have a whole bunch of different threat models. So to be very cognizant of where we are. So let's start with injection flows. We're going to have a whole bunch of things to talk about. These are really cool. So remember how we had buffer overflows. What was the key thing that was wrong? Why were we able to exploit buffer overflow?
It wasn't checking the length of the buffer that we were inputting.
Right, but why is it a problem?
Because then you could overwrite stuff.
You could override stuff, but that stuff had some other properties than just the regular data, right? It was the intermingling of data with control level information, right? Some private information. Same thing happens here. It's like if you send untrusted data to an interpreter, data that somebody else provided. For instance, if I'm supposed to sign on to a page and I'm supposed to put in my name, what if I put some extra stuff in my name, right? What if I put in code, or something that will be interpreted by someone as code? then I have triggered an injection flaw. So let's take some examples of this. This is defined by this OF standard. So it's a result of the possibility of interpreting data as code. Now, let's take examples. So here's a kind of a typical scenario. You're on some site, and that site happens to have some functionality. For instance, it could have this beautiful ping for free stuff, right? What does ping for free do? Well, you enter an IP address and it does some stuff, and then it responds to this client with the output of the ping. You guys know what ping does? Ping.
Checks to see if there's a response.
Yeah, so it's usually a program that sends out special packets. Packets tend to be a protocol called ICMP, which is just a packet that doesn't need any connection or anything like that. Just sends out an ICMP packet saying like, hey, are you alive? And so it's like, yeah, kind of. And sends a packet back, right? So the whole point of it is to measure, is to do two things. Figure out if the other server is reachable and up. And second is to kind of measure how long it took for a round trip. Like you sent the packet and the packet came back, and then you get like the double the distance of like how long it took. So it can be useful to figure out variety. So suppose you have a ping for free application, like for instance, your routers, your gateways at home for your internet. They usually have a ping feature. Now, how would that be implemented? Well, on this website over here, it's probably going to have some HTML form that looks kind of like this. You enter an IP address below, you open up, you create a form, and in this form you have two fields. One of them is a text field for IP, that's what this one thing is, and the other one is a submit button. So if you hit submit, it's going to provide whatever you typed in here as an IP to this current site as a post request. Okay? So now on the server side, there's something that's going to interpret a post request that has an IP set. Okay? The silence is deafening. People still on board? There you go. So it could look something like this. Suppose it's written in PHP, which is a fairly typical choice. Most of Facebook is written in a variant of PHP, for instance. Etsy, other places, right? So you might take a part of the request here, specifically in the field that's provided. It's called an IP. Let's call it T over here. And then we're just going to do something like system. We're going to say, hey, open up a program called ping, which is a standard utility on all nodes. If you don't try to type ping, it's just built in. And I'm going to ping, I'm going to have 3 packets, and I want to provide T here as just the argument, like the IP address that the person put in, right? So of course, if you put in an IP address, it's going to just ping, and then the output of that is going to go into this variable called O, and you're going to print that out, and that's your response, right? So you get something like this. You put in 127001, and this is the output from the running the command. So far, so good. Put on your hacker hat. Now what can you do? Volume a little higher, whoever is. Is it you? Okay. It's like on the Richter scale, it's like, doesn't register.
You can put another command.
Oh, you can put another comma.
Command.
Command. Okay, so how would you do that?
A semicolon.
Semicolon and then whatever command, huh? Wait, does that make sense? Because in essence, this shell execute, it doesn't care when it's executing. You put in a string of commands, well, guess what it will do? It will just happily oblige. Even though the intent here was just to put in an IP address, there's nothing that checked that it was just an IP address. It's just a string from a user, and it's a malicious user at that. Of course, this doesn't come up in testing, because nobody does testing, huh? It makes websites like these, and like, big companies do testing. So, if we put in, like you said, another command, let's say ls. What would the output look like now? We put in semicolon ls. We get our ping stuff, and then, some information. Oh, no, that's very exciting. This gets a lot of teenagers very excited. The kids in Anonymous will hack your website like this. Now that's an information disclosure vulnerability, right? You can know stuff about for instance, what's inside the current folder, things like that. Could you go a little bit further than that? Can you put in shell code somehow? Yes.
No, I did like SQL stuff, you do with PHP, you do stuff from database.
Oh yeah, so, well, there's no database right now, right?
Well, I mean, like, if you do, like what you said, like force parentheses, semicolon, you can pretty much put in like as many commands as you want, right?
Oh yeah, you can keep going with more parentheses, with more semicolons, yeah. So you could have a whole program, right? But how would you kind of turn this into a shell? Like right now what you do is that, yeah, you just keep entering semicolon, whatever you want to do, and that's fine. But suppose you wanted to just spawn a shell, just for fun. How would you do that? Well, this is a fun trick to know. Open up netcat, which tends to be pretty standard. And C is what we tend to use. We just say, hey, open up this program bin bash and put it on port 31337, which, by the way, is blocked by several routers because it's only used for nefarious purposes. So 31336 then, or something like that. So yeah, now what's happening is that this is loading up a program, and the program is going to be listening on a port, and if you connect to that web server on that port, oh look, you have a shell. How fun. Or you could have it the other way around, and just have this netcat connect to your command and control server that you have hacked somewhere else, and that server is just there, it's my bidding my master. And just gets connections from various hosts that you hack, and whenever it gets a new connection, it adds it to this pool of zombies, right? Now you connect to your command and control server, you have all your zombies, and you tell it to do stuff. Yes. Welcome to modern bot herding. Fun, huh? Let's look at a different kind of class of injection here. So suppose we're dealing with a database on the back end. The server has to look up some of the stuff that you do in MySQL or something. Well, suppose the page that you're opening up is like user.php and has this ID 5, right? Well, what happens is you say like, hey, who is this user that has user ID number 5? And the server's like, let me think, oh yes, it's Reza. And so Reza's like, comes back to the server as a response here. And then Reza gets sent back to the client. So, or maybe the PHP site itself rendered a page like, welcome back, Reza. Right? That's a typical interaction. Now, you guys didn't remove your hacker hats, did you? Right? Put the hacker hat back on. What is that quest? What can you do with this?
You can get back queries. You can get back results where you can find it.
Like how? What would you do?
You can choose it if possible.
But it's hard-coded in. I'm sure this part here is probably hard-coded.
Yeah, but you can add that.
You can close that query and set another.
Oh, you can hook up another query, kind of like with the command, right? Yeah, something like that. Or you can just modify the query a little bit, like this, like, where the username is -1 or admin equals true. So now it goes in here, and suppose it's just one admin user. Goes in here and like, select everything from user ID is -1, or admin is true. Oh, all of a sudden the data you provided, the -1 in that string, is not being interpreted as a command, right? This is the problem. So the div is going to be, oh, here, let's admin user. And so, welcome back, admin user. And there could be a check in the PHP site like, if the user logged on is admin user, here are extra privileges, right? Could be really bad. Yeah. Here's an example of why this is bad. Here's a little thing called Card Systems. This is a company that was kind of the back-end thing for a variety of transactions on the internet in the early days of SQL injection. And there was a SQL injection attack in late June 2005 that stole 260,000 credit card numbers from the database. And of course the data was unencrypted because reasons, right? This is one of the reasons for why we always encrypt credit card numbers or don't store them at all, according to the standards that I know of for processing credit card information. They exposed 43 million credit card numbers. This is bad for a company. In fact, it's so bad that it could put out of business. What's funny about this, or not even funny, what's hysterically scary about this is that this is a small attack. Let me show you what's been happening since then. I'm going to show you a little timeline here. Let's look at the world's biggest breacher. Look, it's 2005. AOL, 92 million users. Okay, I'm just going to, okay, here's like, that's for spammers and stuff. Well, we're just going to go up and, oh, here's the card systems over here. 40 million. Like, KDDI, TJ Maxx, 94 million, Heartland, Rock Hero, AT&T, Betfair, Dropbox, Antisonic, massive American business hack, 260 million thing from 7-Eleven and whatnot, Blizzard, Apple, Adobe, Yahoo, eBay, AOL, Home Depot, and this is just today, right? That's just like the ones that are big enough to kind of make a dent. Like there are things in here that are just like, yeah, well, who cares? Like this is insane. Look at the pages that have been hacked. MySpace, all sorts of fun stuff here. And you can actually go on this page here and tell it to include. Oh, there's like a. Say again?
Was one of those a security company? Because that would be something.
Oh yeah, there's security companies in here. There's Ubuntu. Let's see if there's a security company somewhere. Oh, Sony Pictures. Oh. Sony is this funny thing that they had like a security officer who filed for special exemption to allow users to have really, really, really crappy passwords because they're artistic types and they won't remember long passwords. We have people with 4-letter passwords. Anybody in the world could have hacked Sony, and boy did they. He has been fired since. Anyway, so yeah, there's a whole bunch of stuff in there. Yeah, there are banks and all sorts of places, Syrian government, whatever. Okay, so just to give you a little glimpse of what's happening, right? Let's do a little sequel. Yeah, go ahead. What do you have to know the what? Oh, yeah. So here, like this is using some crystal ball thing, right? Let's go into the details of how you figure this stuff out. That's a good question. So let's do a little just overview of SQL, because you may not have seen. How many people have seen SQL before? Okay, a whole bunch of you. Great. So let's just have a quick review. So SQL, it's this 1980s approach to databases that has become the standard for how you deal with it. It's a query language for a relational database where every single data entry is stored as a tuple, or as a row, as it's called in SQL parlance. So in every single row, you have a number of well-defined columns of information. So for instance, if there's a column here of a particular type, you may have some value here, you may have a value there, and so forth. And so you have here 2 rows, 3 values each of them with the correct type corresponding to its column. So as an example, suppose you have the users table here. The users table usually comes with some sort of ID or identifier. In this case here, user ID, which is usually the roll number itself. As well as maybe the first name of the user, the last name, the username itself, a hash of the password. Oh, what a novelty. What would you take the hash of a password?
When you're not storing the password, so.
Yes, you're not storing the password because you're going to get hacked. So when you get hacked, you don't want everybody's passwords to just leak out mysteriously. Okay? You don't need to store them. All you need to do is to take whatever the user input that the user provided, hash it, and see if the hashes match. Why don't people do this all the time? And maybe an avatar, like, oh, I have this admin.jpg picture. That's the picture of Mr. Admin, right? And so forth, right? There's, of course, some notorious user hacked me. Username 1327, you know, so neat. Okay, great. And the types of columns here are var char15, means 15 byte character areas. And I'm like, see, there's no kind of length, like the length limitations are enforced. There's no buffer overflow to speak of. And there's just an integer. Great. So what can we do with this? Suppose there's yet another table here. And this is where the whole relational aspect comes into play. There's a table here called comments. And it has, again, a user ID, comment ID, and then the text of the comment. Now, why do you need user ID in here? What's the point of that? the point is that we can now actually relate the two tables. We can relate user here on this column, on the user ID column, and say, hey, I want to know all the comments written by user ID 3. I also want to know who that is. I could write a query like that. I could say, user ID 3, who is this guy over here, hacked with me, and I want to know everything that this person wrote, which is only this row. So you can make queries of this form, right? Now, when you put together a whole bunch of tables and these relations between them, what you've ended up with is called a schema, which is just how are you going to use this database? How are you going to, what kinds of queries are you going to be running, how are they connected, and so forth. So, a basic query in SQL would be select, which is a projection. What you say is that, hey, I want to know all the rows that fulfill some particular criteria from these sets of tables. So we could say, hey, I want to get these columns from these tables as long as these conditions are met. Right? So it could be a list of different column names. It could even be, I just want all the stuff, right? I'm greedy. I have data lust. Right? Or it could be, for the tables, you could say, hey, here's a separated list of tables. You can even give each of them a name for the query, just as a shorthand. Expression is a Boolean SQL expression. It could be something like, I want this to be equal to that, or greater than that, or I want this one thing over there, and I want some other condition to be fulfilled. Right? So, if you want to do comparisons for strings, you usually use string and quotes. And then, of course, you have all this stuff that maybe not everybody kind of knows about, but you can have comments inside SQL because it's a proper programming language. So in MySQL, it's a hash mark, it's 2 dashes for standard SQL and so forth. Just FYI. Why am I throwing it in there? We'll see. Anyway, so let's take more examples. So here's the select query from the database from before. I want to get all the queries now where the user ID equals 2. So in other words, I get every single column from the table called comments where the column called user ID is equal to the value 2. So what will I get back? I will get back these rows here, these relations. So 2, I like sure. Right? That's a string. Makes perfect sense, right? Exactly. So then we have this notion of a join, which is what happens when you want to take several tables together and you want to kind of assort them in some particular way, right? So, for instance, let's say you wanted to know the username, you want to get the comments and you want the username of who posted it. Because if you look at this table over here, there's no username, right? So how would you do that? Well, you can do that through select, actually. Select supports a built-in join. You can say, hey, I want to know the first name of a user in the users table, and I want to know the comment itself from the tables users and comments. So that's supposed to know 2 tables. And now I want to link them together. I want to say, I want them to be linked in the following way. I want the user ID in the users table to match the user's ID in the comments table. So now the relations I get back are going to be the username and then the corresponding comment. And I can have a whole bunch of these. So in a join, you could have all 12 relations. But we're going to have an additional constraint saying, like, I only want the comments from user ID number 2, which just happens to be Gordon. So what I get back is Gordon, I like sugar, Gordon, but not milk. Whatever Gordon types, I get his name and I get the comment. Makes sense, right? Now we learned SQL. Here's another useful thing for hackers. Well, if I have a select query and I get all the comments from user ID number 2, suppose I wanted to add something there that would just make the expression match everything. So instead of filtering out only things that are user ID number 2, I wanted to just go back and give me everything. Well, I could say, like, I wanted to get username number 2, or anything really. I can say, or if it's true for this row that 1 equals 1, yeah, I kind of want that row best, right? It's a tautology. It's equivalent to saying or true, which actually also works, right? So why would this be useful to us? Let's have a quite look here. Well, this query would now actually produce the entire table. So you get back the whole entire comments table. So let's see how this could be used. Here's an actual code from some PHP page, and we're going to figure out how to hack it. So, what do we do? exactly what I'll write. I'll write,
Or 1 equals 1.
okay. So,
ID.
so then we're going to have, what's actually going to get issued to the MySQL server is the query select first name, last name for users where user ID equals
ID or 1 equals 1.
ID or 1 equals 1, right? So you put in something. You can say where ID equals 1 or 1 equals 1, right? So now what we've done is that we've gotten all the first names and all the last names from the query. This is the output that we're going to get. You're going to first name admin, surname admin, and so forth. Some will be customers in our table for whatever reason, and so forth, right? Cool, huh? Yes. Imagine how fun it is to find this on the login page for your bank. Your bank. Now, okay, let's fix it. So, what happened here? The query was just user ID equals ID. I'll just put codes around it, right? Much better, right? Hackers do not. What do you do? If you're a hacker and you saw this, you're like, yeah. Well, how would you, just put another quote, right? You put another quote, you put like 1 and then a quote, and then do your or equals, or 1 equals 1. But then you're left with this extra quote that's going to break your query, right? Put what? Like put a, oh, you put a comment, right? They'll get rid of the quote. Or you could have like 1 equals open quote 1, and then you get the close quote or something. You can do all sorts of things, right? So comments are very useful like this, right? But then I would put in like 1 quote, and now we're outside the ID field again, or 1 equals 1, semicolon, comment everything out that's all the stuff that I just put there, right? Yeah, MySQL will happily oblige. Fun, huh? Yeah. Or you can go even worse. Instead of just like getting all the usernames, you could really go all the way in and say like, hey, or 1 equals 1, drop table user, watch the world burn, right? With permission from the world, of course. Yes, yeah. Mm-hmm. Ethically. Of course, I don't know if this actually works, but you get the idea. Which actually brings us to this nice XGCT comment, right? Have you seen this? About Bobby tables. Can you ask that was your name? Would be funny, huh? A bit version specific, but yeah. Can't fault them, right? Remember the names in Iceland, they're capped at 32 characters. And I found out why. It's like, yeah, we have this program that we can change, and it's like, it's capped at 32 characters. So we predefined that. Anyway, so, now, one of the questions that came up, which is very prescient of you, was, hey, how did you know that you should put in user ID, like user underscore ID? How would that even be known to you? Because you're just an attacker seeing a page, and you put in extra stuff and you saw things break. And now you suddenly know the table name. Well, let's see what techniques we have. Because essentially quite a little bit out there. First thing that we're going to figure out is how many columns are there in the query that we're situated inside. Because we can't see the query usually. And then what are the names of the columns? And then also, what about the other tables that we might have interest in? So for column, just probing the number of columns, here's something we can do. We can add the order by. So as a part of the select query in SQL, you could actually tell it, get me all those results that I've asked you about, but please sort them according to the following. You can order by, and then you can specify table name. Or you can actually have a shorthand which says, order by the first column that I have, right? So here's what it's going to look like. You put in this query over here, and it's going to get, it's going to become this query over here. Select first name, comma last name from users, where user ID equals 1, order by 1, and then empty out the extra quote. Now if I put in the number 2 or 3 here, let's say I put in 3, and there's only 2 columns being queried, I'll get an error. Therefore, I know how many columns there are. Yeah, well, I could then just check 2, right? Suppose we could have tons and tons of columns. How would you check? Very good. I like the way you think. Yeah, right. The fastest way to doing it, suppose there's like at most 32 columns for whatever reason. How do you search? Yeah, it's 5 queries. By 16, oh, too high. By 8, oh, too low. Must be somewhere between 8 and 16, and so forth. Very fun. What about the names? Well, you can keep trying. You could brute force them to say, well, when the first underscore name is null, well, that's going to be fine. But if you drop the underscore, it's going to be bad. Unfortunately, there's this thing, well, or unfortunately, depending on what side you're on, which side you're on. You with us or against it? There's something called information schema, which is this kind of master table that, it holds all the names of all the different columns and all the different tables. And it's always called information schema. Oh no. And then there's a question, what about other tables? You're stuck in this kind of users table over here. Maybe that's not where you want to be. You want to be in the passwords table. You want to be in the table that, I don't know, has all the credit card numbers with permission. Yeah. So suppose you now expand your knowledge of the SQL and syntax, and you realize that, like, well, sometimes when you're a select query and you want to get the output of your select query and merge it in with the output of a different select query, there's a keyword called union. Or there's also one called intersect, and there's several other kind of set operators. And what union will do is that it will take all the results from your first query and then also mix them in with the results of the second select. So if you don't have a semicolon that's functioning for you, just use union. Oh, how fun. So here could be your query. You say, select first and last number users for the user ID is 1, and also give me all the usernames and passwords from my SQL. Now, why did we have to know about the number of columns? Well, it was actually specifically so we could figure out what to write here, right? Because if you take a union of something that has a different number of columns, it's going to have an error. Right? So here, for instance, if there's vastly more columns here in the first query, you could just say username, comma, password, comma, 1, comma, 1, comma, just add it in with a bunch of empty columns or constants, and you'll be good to go. Fun, huh? Pay close attention, there will be a lab about this. After your lab, of course. Focusing on the bliss. Good, so notice how all of this kind of relies on us getting error information. Think about that for a second. The error information is our best friend. The fact that we know that, it's getting an error in this way or that way. Like, you think about making a website and you're like, something failed. I better let the person know what failed. Well, think about the security ramifications of this idea. Right? This is unbelievably useful to attackers. So, for instance, if you did a select query, hey, I want to get this in order by 3, I got the error message, unknown column 3. Well, that's unbelievably useful. Or unknown column first name. This helps me a lot. Now, suppose that you suppress all error messages. Can we hack SQL? The fact that I've gone one slide ahead and then come back very fast suggests that the answer might be yes. Yeah. It's called blind SQL injection. What on earth can you do if you have no error messages coming back from the server?
You can check the time it takes for the work.
The time is this nice little side channel that could be very useful. I love that idea. So for instance, here's somebody authenticating here. Hey, who's user of the file? Oh, it's Ymir. I'm going to do a select query here and then get it back, right? But suppose I don't get the thing coming back to me at all. Don't get the results of the select query. Don't even get the error messages back. Then we're in the realm of blind SQL injection. And we either get like a generic error page that doesn't tell us anything, or even nothing at all, right? So the approach is exactly what we're saying. We're going to say like, hey, let's take a look at some of the side channels, for instance, time, and just ask a whole bunch of true-false questions. Since we're either going to get no error or some error, or we're going to get this took a long time or took no time at all, right? Primary. Let's see how that would work. Suppose, for instance, I want to know what the username is. So what I could do is to say, hey, if the ASCII character of the first character of the username, the substring 11 here, if that's equal to 64, which is A, 65, anyway, then delay by 5 seconds before doing anything. Otherwise not, right? Now, either you're going to have to wait for your page for 5 seconds or you're not. Therefore, you know the first character is A, right? And of course, and then this is what happened. First letter is A, it's 65. I don't know why it says 64 here. 55 seconds delay. Now notice, you can also do exactly the same thing as before. Binary search. Right? You could binary search each character. Sounds like a really well-spent afternoon. Yeah, right? Now that's actual true syntax. This is fine. And this is what is done, right? 65, right? Now, yeah, so now you, for instance, you hit the red one, you learn that it was one. So, this sounds tedious a little bit. It's actually really fun to describe it, but there are tools that automate this really well. They're extremely noisy when it comes to logs. Like if you run this, for instance, with an Emory, there would be people running to you in like weird outfits, right? So all the security things are going to just line up like a Christmas tree. Because it's like, oh, I'm seeing so many SQL queries, it looks like SQL map. But we're going to learn about SQL map. You're just going to be very careful when you use it. And don't use it against anything you don't know, okay? But what it does is that it automates this whole thing. It tries to enumerate entire tables, figure out who the users are, who the admins are, and so forth. Using all the different techniques it knows about, all the different databases and so forth. Even if there's some striping of input, if you, for instance, stripe away all the spaces, what does it do? Oh, it's like, oh, it's taking away my spaces. I'm going to put in comments instead. That's still no space. It figures out little things like that. Right? Now, suppose we put on our defense hat for just a moment. One of the best things you can do is to parameterize your queries. You can say, hey, I'm going to be issuing this query to the SQL database, and I kind of don't want it to be hacked better until like the next person takes over the job. So I'm going to put in a prepared statement that says, hey, this is going to be a query that's going to look like update player, set the name equals this, and active equals this. It has 4 parameters. Instead of just specifying them blindly by appending it to the string, you're going to say, hey, the first question mark, that's a string. And that has, well, this value over here. For instance, that could be a string from the external user. Now, what happens internally is that this gets sanitized. Quotes are put around it. It figures out that this is supposed to be good, right? Set integer 42. It figures out that, like, yeah, I don't have any problems with integers. It's okay. That Booleans are thing. So, now, of course, this exists for any other type of SQL syntax. So that's cool. Anything that allows you to stop mixing data with code is a benefit of security. This is kind of the mantra that we need to be taking away from this lecture here. It's like, don't trust anything really. If you trust the database, you trust the user, something like that, you're in a world of hurt. So just when you write your code, be skeptical about everything. Every input that you get, every output, every interaction you have with even the database that you thought you trusted, everything can be compromised in a weird way. So let's spend some time talking about a different kind of attack. So what is injection? 2 different kinds of injection. Let's talk about cross-site scripting. Before that, let's take questions if there's any questions.
Alright, so if since they're hashing passwords,
Yes?
so technically I could get in with a password different from my actual password.
Yes, with very, like, overwhelmingly small probability.
Because it's like a really large binary.
It's just that the probability of a hash collision is very small, depending on the number of bits that are used for the hash. But we will actually talk about a fun hash collision attack called the birthday attack in a few lectures. which reduces that somewhat. Look, that's safety. But in general, yeah, that can be true. Now, of course, if your hash function is something that you cooked up, like over breakfast, and you say, oh, this is fine, it hashes everything. It's probably not a good hash function, no matter who you are. Don't roll your own crypto, they say. And that means that you're going to have collisions. And you're going to have, somebody authenticating like, oh, I can authenticate as Derek. Everybody will logs onto the page because authenticated as Derek. It's funny, always. It's just because there was a hash collision like that. This happens. There are people who are that bad players. But use the built-in cryptographic hash functions to do stuff. And then update them as they become unsafe when NSA starts overturning them backwards. Anyway, car-side scripting. You'll learn about 3 things. Document object model, the DOM, cookies and sessions, and then the actual attack itself. So let's think about your browser a little bit more. So what's happening to your browser? Browser is effectively like an operating system. It has its own memory allocations, has its own process control. It's like its own beast. This is why Chrome and all stuff just like takes over your computer, right? This is why Google also makes computers like on Chromebook that are effectively just running Chrome and a little kernel on top. Yep, it's an operating system. So it comes with all the bells and whistles of an operating system, including the whole model for how things work. Now, what you normally see is some sort of window or a tab, right? What's happening inside that tab is that there's some content. The content is usually retrieved from some website, and there's a renderer that takes in the HTML, figures out what the HTML means, moves them into this kind of tree, takes all the scripts, also moves them into whatever program language, and interprets them, and then runs them. Runs the renderer stuff on them. And then finally, as you scroll up and down and click things and hover over things, it responds to events that it generates. For instance, on mouse over. If you go over some picture, it's like, blah, or whatever it is that things go. Or like, oh, I clicked on something. Oh, I'm going to make some graphics that are going to slow down your computer. Right? And then repeat. That's what effectively your window is doing. So here are some of the examples of events that I just mentioned. Like what happens if you hover over something, it's called on mouse over. Or once the page is loaded, you get an event called unload. You can set timeouts, blah, 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 a whole bunch of stuff. Now, the DOM, or the document object model, is this tree that I mentioned before, which takes your XML page here and then splits it up into something like where there's this hierarchy here called document and this head and body. This is a model of web pages that is insanely complex because it is so flexible. A browser will try to accept any deviations to this tree and be like, yeah, even if you skipped all this like end tags and you did everything wrong, and even if you completely dyslexic, I'm just going to render this page for you. I'm going to do my best to figure out what you meant, which means that you have half of the internet being like completely malformed HTML. So all of the browsers have to chase this, be like, oh, I have to support dyslexic HTML, and then you have to do all this like nonsense to figure it out. This is a model that's way too flexible to have any kind of security. We invited a speaker in the spring from Harvard who was talking, because one of the researchers has been kind of investigating browsers and so forth, and he just like effectively like brings in like if you're in a coffin, like, he's like, this is such a lost cause. Like, let me tell you about and then any part of this stuff. This is a security nightmare. Browsers are terrible. Part of that is to blame with trees and a variety of other things, but it's a sad reality. Anyway, now of course, just to make things a little bit more complicated, this is a tree that comes from the HTML, but it can be dynamically updated. Remember that heap overflow I showed you right after we finished class last time? Well, that was because if you made changes to this tree, then one of these, like if you did it in a particular way, you interjected like a button between a form and whatnot, like some crazy thing, right? Then one of these pointers wasn't freed properly. That was it. In Internet Explorer, by the way. So you'd have to test on all the different browsers, all the different versions to figure that out. Right? And consequently, you had a use of the free button. Fun? Yeah, great. You've had a lot of these. Every month you have new ones, right? So this is dynamically updated. Now, for instance, here's a page where you dynamically update something on the page. It's a page that pretty much just prints the string allies, right? Except there's this anchor over here called AID. It just identifies what this thing between this and the delimiter here is called. It's called my ID. And if you click on it, so the reference here, you run a JavaScript that calls flip text, which is this routine up here. It's a function that checks to see if the my ID, so it calls the document and then finds the element that is called my ID. And it tells it like, hey, what is the first child of that? And you figure out like, oh, if flip is 0 on this global variable, then I'm going to make that value of that thing over here. I'm going to make that Alice, is Bob, or like Bob into the house. Just toggle back and forth. This is legitimate JavaScript, right? You have hordes of people writing this kind of code. There's no type checking, there's nothing. This is very interesting stuff from a security standpoint. Anyway, just shows the flexibility of what you can do. Okay? Now, cross-site scripting is this class of attacks where you're effectively making somebody else display content that has some extra HTML or JavaScript in it that they didn't expect. In other words, you're trying to get somebody else to execute JavaScript or HTML code through watching somebody else's website. It's kind of weird. So let's take some examples. Suppose you have this page over here where you can enter your name. Hey, what's your name? My name is David. I'm going to say, hello, David. Right? Like the world's most interesting website. Right? This is the Webby Award 2010. So, what's happening underneath here? There's going to be some form submission, because we see a submit button, right? The form, it takes in like, hey, what's your name? It's a text field. It has the name, and the submit thing, and it's going to get sent by GET here to the other form. And then there's some JavaScript on the other end that's going to be picking it up and saying like, hey, well, not exactly, it could be these two things. It prints out a form here and says, hey, hello, David. But what if we put a little bit more into it? What if we put in special characters? Like, for instance, like these angle things, what it's called, less than greater than. Well, in this particular case, they didn't get stripped at all. Why would you need to strip them?
Because otherwise you can inject your own HTML commands.
Oh, if your name is David Body something, or B, you could B, and then you become boldface, or ha 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 ha. You can do all sorts of like stuff, right? It'll like remind you of like an old MySpace page or something, right? You can change things on the page, right? Yeah, exactly. So here it seems that it's not strict. It's normally what's supposed to happen here is that you should be getting the HTML code for an angle, which is like ampersand LT semicolon or greater than, yeah. Okay? But that's what's happening here. So what we could do is to, instead of logging in as David, we could just log on as script alert hi and script. What have we done? On the receiving end, we now have a page that is going to take our input here and it's just going to echo it straight back into the page itself, and it's going to be a part of what is executed on the page, and the privilege is what the page is. And it's going to execute the JavaScript and say hi to whoever opens it up. Why is that bad? Well, this page here has access to all sorts of stuff. There's access to who is the user, what was this user's authentication information on that particular page. What is the, what kind of browser do they have, and so forth. It can even like make new requests. It can launch a distributed denial of service attack against whoever you want, right? You could just have a look where it's like, keep sending packets to, who do I pick up? Didn't do you? Ray, right? Find Ray's computer and just keep sending him stuff, right? In the background, in the JavaScript, and your computer's like, but really, like, you have no idea why. That's fine. Okay? So, this is effectively what gets rendered on the other end. Make sense so far? It's a little bit of a weird attack when you first look at it. So we were injecting code into somebody's HTML page. Okay? Let me take a little detour here and introduce cookies. So most of you have dealt with cookies. And everybody loves cookies, right? You like cookies, right? So HTTP, because it's from the like 1700s on computers, it is a stateless protocol. You have no state. Like an HTTP server, absolutely no idea. Like when you send it a request and it goes away, you come back and it's like, who are you? No memory, right? It's like memento, right? You don't even have like any like of your tattoos or anything to figure stuff out. You have no idea. So what people do is that they try to inject a little bit of state, some information into requests so that the server can have a little bit more context about who you are. For instance, if you didn't have that, then every single time you click anything on a website, on like your bank or something, you'd have to re-authenticate. Wouldn't that be fun? Wouldn't you be inclined to use online banking? Every single time you hit like, overview of accounts. What's your username? What's your password? Let's do it again, right? Or you would have the shortest password in the history of man, like hey. So we have cookies. Those are meant to try to circumvent the stateless nature of HTTP. So how does it work? Well, you usually you go to like your bank or something and you get a username and a password and it's stored in the database. And then the first time an HTTP page or like your website sees you, it's going to ask you, hey, what is your username? What's your password? And you're going to transmit it back, usually over SSL, so that it's not visible to just everybody in the world. And along with that, if that's a successful authentication, you get back a cookie. And the cookie is a long string, and it's hard for external people to guess. And that is now equivalent to the token that's required to authenticate as you. Right? So if I knew this cookie, I could now go to Thailand, go to the bank, tell them the cookie, and they think I am you. Right? They have no reason not to believe me. It's like, oh, this person just teleported to Thailand. That's really funny. Well, let's send it to them. Right? That's how it works. So every single request, until that cookie expires, the browser automatically sends as part of the HTTP request the value of the cookie so that you can be re-authenticated. It's like, it's still me. Oh, yeah, okay, cool. Right? So that's how we keep state. Okay? So of course, knowing the cookie is equivalent effectively to knowing your username and password. Like you get all the same privileges. This is also why when you're on pages, you're like, you've just authenticated and then you're going to do a transfer and it asks you for your username and password again. That's so annoying. Right? Why? Because you were probably authenticated by a cookie without realizing it. And now it's confirming that you indeed are not somebody who stole somebody's cookie. Right? So if you're annoyed at extra authentication checks, there's a good reason for it. All right. So you send a posting, it sends a set cookie header back. And the next request that you're going to do is the GET request. You put in one of the headers as a cookie. And we get the response. Really cool. So let's get back to cross-site scripting. How would you steal your own cookie? Well, instead of alerting at just hi or some string like that, you put in document.cookie. So the basically says like, hey, use the session ID, and here's the long string that's unique to the user. Ooh. So now, if this was an attacker seeing this, they could authenticate as that person's credentials on that page, right? Cool, huh? So how does this work? Like, so I've told you about something, it gets injected into HTML, and it could be a little bit confusing. So there's different forms of cross-site scripting, and we'll talk about two of them. One of them is called reflected cross-site scripting. What it means is that I can send you, suppose I'm now in conversation with somebody. I'm sending you an email, okay? And in this email, there's a URL going to some page. And as part of that URL, I'm actually putting in a cross-site scripting thing. I'm going to put in like JavaScript code. That when you put that link and you talk to that page is then going to reflect that extra information provided back, and you will then execute that code on your browser because it was reflected by the page. Did that make any sense? Give an example, right? So we're sending you victims a link containing a cross-site scripting. Suppose this is a real thing until like 2009 or something. LAPD. Right? Let's hack the LAPD. Or like let's use LAPD to our advantage to hack something. what are we going to do? We're going to say like, hey class, hey CS453, it's a very important page you guys have to look at for class. It's very important for Joy Lab. You should really check it out right now. Like time is running low. You should click this link, and then in this link there's the LPD online, search results, and as a part of the search terms, there's the script tag, alert vol or whatever it wants to do, and then the script tag. And what does LPD do? It alerts you back. Right? If you search for David Brumley here, you can also set, but you also get the alert high, or whatever it is that you want this page to do. So the attack works as follows. There's an evil person using a legitimate server to reflect back code to some victim that the victim will then execute on the browser because the page reflected it back to them, without stripping out all the special characters.
What's bold? Is bold just like the name of a file, or is that where you actually put the program?
So this is just an example of what you could execute. What you would put there, instead of putting up an alert box, you would put in something like, hey, let's take your PHP session ID and ship it to some other country, some other site.
Some other site or to you?
Site. So probably a site that we collected. And there'll be a site I have access to as a site. Okay. So we're getting somewhere, right? Here's the exact query, right? LPD online search results, we're going to filter content based, and then search terms equal script, alert, document, cookie, and then script. Okay? So now, here's the person. Hey, check out this link. Check it out right now. It's very, like you have to do it right now. Be very scared. It's IRS. You're like, you owe a lot of money. Like something that's really going to like wake people up to make the click stuff. So phishing it. And this is the link that is sent. And it looks legitimate because it has LPD online in it. Right? Or maybe it's just a link, but when you look at where the link is actually sent to, this is what it is, right? And then that person is going to come talk to LPD online and send this exact query with all the process scripting information. And then you get back a page, the response page, that now has the malicious JavaScript code inside of it. That JavaScript code is going to say, for instance, let's say that document.location equals evil.com document cookie something, right? That means that you're now going to redirect to the page evil.com and then the value of your cookie. And this is our hacker-controlled server. We've now learned your cookie. Relatively bad, huh? Yeah. Fun, huh? So now your session token ID, right? There's another variant here, which is called stored cross-site scripting. So instead of just reflecting into a single user, what if you could just log onto a server, for instance, YouTube, you could put in a comment, and in that comment you could put HTML or JavaScript or something like that. Wouldn't that be bad? Because everybody was still like, oh, check out this Gangnam style thing. And there's like a comment at the very top that's like, send all your stuff to some other site. Up. Now everybody who opens the page is going to be executing that malicious JavaScript. So here's an example. A guest book. A lot of people write their own guest books. Hi, I'm David. Software security is hard. And you can put in your own HTML here, like boldface. And you see here, software security is hard. Looks like it doesn't strip away any of your HTML tags. So what if you now put in here something more nefarious than the bold one? You put in alert test. Now everybody's going to check out the guest list. It's going to get this pop-up. Yes. So we're going to take that, right? So in other words, we have like this evil guy, and he posts on some page, some guest pages, like LPG online or something, says document online. Post a comment on LPD that says, hey, go to evil.com and send me all your stuff. And then everybody opens it up. It's going to have that JavaScript parser. It's going to connect to evil.com, right? And in fact, what's happening is that you're storing on the server, and all the different people who are going to open up the server are going to be hacked, right? It's a watering hole, I think. Fun, huh? Yes. The internet is it's a crazy place. Now, if we talk about the defense a little bit more. So in injection, the issue was that we didn't sanitize input, right? We didn't put quotes We didn't use stored procedures, things like that. Consequently, this is something that was being evaluated by another person's browser or another person's server, something like that. Now, in this particular case here, we are injecting code, or something that's going to be interpreted as code, because of the way HTML is just like a series of text, and it's going to be interpreted as special tags and so on, right? As it turns out, if you were now tasked with the objective of trying to fix this problem, chances are you would fail. Just like I said, don't roll your own crypto. Yeah, don't write your own sanitization. I guarantee, like, let me just show you how hard it can be, right? Suppose we want to get rid of these script tags, right? We don't want people to be able to, we're running a guest book thing, and we don't want people to enter something that's going to be interpreted as JavaScript, right? So what would be the first thing we could try to get rid of it? We see somebody enter something like a guest book entry, and we want to strip it of everything it could be possibly nefarious. How would we proceed?
Check the brackets.
Check the brackets, we check the brackets, right? But we want to support things like boldface. We just don't want script stuff, right? So the first thing we do is like, hey, let's just remove script, right? Easy peasy, right? Can anybody repeat this one? Did you check for uppercase script or alternate key script? Oh, you did, good. Okay, then I'm going to do this one here. Oh, no. Oh, that's so sad. Look what happened to you. Well, what could we do in response? Is what? Well, it will be once you've removed all my scripts. Oh, you need to take it recursively. Yes. Okay, what do you do with attackers? Say, oh, recursively checking things good. Ah, if we could only execute JavaScript some other way. I see Ray smiling in the back. Oh, look, body, unload. Once the document is loaded, run the following JavaScript code. Automatically. Oh, it's the same thing. I'm recursively going to remove script and all JavaScript keywords like alert. Right, yeah. You did, and even so, this one here bypassed the whole thing. If you put in body unload or something, it's going to be interpreted by the browser as being like, oh yes, I have successfully loaded the body of the document, I'm going to run this JavaScript entry here. Right. So, not just even the script tag, you know. So now we're going to we remove script, and we're also going to remove everything that says something like alert, right? We're going to go all out here. What is happening? Why is this? This thing here is like an example of like what Apache Tomcat did. Is that because browsers are so gracious in trying to interpret what you're doing as HTML, like I know you can't write code worth anything. I'm still going to try to make a web page out of it. It's going to be like, oh, you put in a special character. You probably meant to put in a US ASCII character. I'm going to drop the most significant bit. So from this 1/4 sign over here, you actually end up with a less than sign, because that's what happens when you take the most significant bit away. Oh, look, and here's the rest of the script. Oh no, alert, and you just put this stuff, and it's just going to remove these characters that are in between here, or it's going to replace them with something else. This starts with L, or oh, you have Unicode, and it's going to convert the Unicode back to ASCII, whatever. Like it's going to do all this stuff. It's impossible to deal with. This thing here executes on the Internet Explorer. This will alert you XXX. Does it make sense just how hard this is going to be? It's impossible. This is one of the reasons why people have said like death to Internet Explorer, right? It's particularly bad at this, right? This is why we have Microsoft Edge, mysteriously. Yeah, kind of fun, huh? Anyway, we're kind of out of time here. We'll talk about more standardization next time. Any questions about any homeworks or anything? Just find me for office hours at 1 p.m. And I'll see you next week.